This is a video lecture for Math 181 for Wednesday, April 29th. And the topic today is how to calculate the average value of a function. Now, let's ask a simpler question. How do you calculate the average value of a set of numbers? x1, x2, x3, and so on down to x sub n. How do you calculate the average value of a set of numbers? Okay, what we can do here is use a simple formula, and hopefully you guys all know this formula. The average value of x is equal to x1 plus x2 plus dot 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 down to x sub n. All of this divided by the number of numbers you have, which is n. So this is a formula you learn in basic mathematics that hopefully you guys all know. Well, now let's apply this principle to calculating the average value of a function f of x over an interval AB. So now we're interested in calculating the average value of a function f of x over an interval AB. And here's the strategy we use to do that. We're going to divide our interval into n equals subintervals. Okay, where the width of each interval, the width of each subinterval is equal to the endpoints b minus a divided by n. Now we've seen this before when we did our formula for finding the area under a curve. So we're dividing our interval AB into n equal subintervals, which each have a width b minus a divided over n. And this creates a set of points along these subintervals that represent these subintervals, x1, x2, x3, and so on, all the way to x sub n. So the idea now is the way we're going to find the average value of our function is we're going to evaluate our function at each one of these subintervals, okay? Add up all those numbers and then divide by n. So the average value of our function, which I'll represent with f with a bar on top, will be equal to f of x1 plus f of x2 plus dot 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 plus f of x sub n. Okay, we're going to evaluate our function at each one of these subintervals, and then we're going to divide by the number of subintervals we have, n. So this is the same idea as this formula. Okay. Now if I solve this formula for n, this means that n is equal to b minus a over delta x. And I'm actually going to plug this into this formula, so let me erase what's upstairs here real quickly. So if I do that, if I plug this in here, I find that the average value of my function is equal to f of x1 plus f of x2 plus dot 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 plus f of x sub n. All of this divided by b minus a over delta x. And now what I can do is I can take the reciprocal of this function. And if I do that and multiply by what's upstairs, if I do that, I get 1 over b minus a. Okay, so that gives me, I just pull this out in front, and then I have delta x times f of x sub 1 plus f of x sub 2 plus dot 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 plus f of x sub n. So I get this for my average value of the function. Okay. Now we can write this in shorthand. Instead of writing out the sum, I'm going to use a summation sign. So now I have the average value of my function equals 1 over b minus a times delta x times the sum from I equals 1 to n of f of x sub I This is now the sum from I equals 1 to n of f of x sub I. Okay. Okay, let me erase what's down here. We're almost to our formula. Oops. Okay, and now what I'm going to do is I'm going to take the limit. So this is the average value of the function. This is approximately the average value. I'm now going to take the limit as n goes to infinity, which will give me the exact average value. So I'm going to imagine that I'm taking an infinite number of subintervals. The width shrinks to 0, and just as we've done before, this gives an exact calculation of the average value. So now I'm going to take the limit. The average value equals the limit as n approaches infinity of 1 over b minus a times delta x times the sum from I equals 1 to n of f of x sub I. And now I can do a couple things. I can bring this 1 over b minus a outside of the limit sign because there's no independence here. So I get 1 over b minus a, limit as n approaches infinity. And I'm going to now move the delta x inside the summation sign, which I can do because there's no I dependence on delta x. So I can move it inside or outside of the summation. So I'm going to write the sum like this. I equals 1 to n of f of x sub I times delta x. Okay, this is what I get. Now I can step back and note, let me observe that this, what I have right here, okay, you guys have seen this before. This is simply the integral. This is just the integral, right? The limit as n approaches infinity of the sum from I equals 1 to n of f of x sub I times delta x. This is simply the integral of f of x dx from a to b. And so now I obtain a really nice, beautiful formula. This says that the average value of a function over some interval ab is equal to 1 over b minus a times the integral from a to b of f of x dx. And the key point is this is the average value over the interval ab. We have a different interval, we'll have a different average value, but we've now obtained our magic formula. This is how we calculate the average value of a function over a given interval. Okay, this is part 1 of this video lecture. In part 2, I'll do a couple example problems. I'll do an example problem, and I'll also talk about the mean value theorem for integrals.